In this final video in the section, we're going to talk about ethical considerations when making or considering graphs for, well, any audience really. And there are three items I want to address, although there's a whole multitude of items that one could consider. So these are just three examples. First, always start your vertical axes from zero. Otherwise, what you're going to do is distort the scale. And in general, you shouldn't do anything to distort the scale to try to fit a preconceived message. Second, include units consistently on all of your axes and be consistent in your plotting with the way the units are labeled. And finally, if you find correlation, some apparent relationship between two different quantities in a scatter plot, that does not necessarily mean one causes the other. Let's look at one example of each in turn. Here is a graph of Ferris State enrollment on the Big Rapids campus from 2013 to 2020. This is the academic year beginning in 2013, that is. This paints a very stark picture. This is something those of us on faculty hear a lot from administrators. You see what appears over the last several years, a pretty sharp decline in enrollment. However, take a look at the axis number, the numbers, the values on the vertical axis. They begin at 7,500. What if we began that axis at 0? The graph on the right begins the axis at 0, and while you do see a decline in the more recent years, it's not nearly as steep or frightening as the decline on the left side. That said, I want to emphasize that's still a concerning decline, but the graph on the left distorts how steep that decline is. Changing the graphs or making choices in graphs that distort the story is an unethical use of the data that you have. And one way to make sure you're not distorting the image in the graph is to start your axes from 0. To do so in Excel, look back at the video about log scales. You use the same approach with log in terms of getting into that format axis menu, and then you can set the minimum and maximum values for each axis. Let's look at the next example. This graph was presented in Congress, believe it or not, to argue about defunding Planned Parenthood. Now, wherever you stand about Planned Parenthood and how you feel about abortions is your business. What I want to focus on is what makes this graph misleading. So the message this graph is trying to say, and it says so in the title, that abortions, so let me back up. One of the arguments in supporting Planned Parenthood is that they do a lot more than abortion. For example, cancer screening and prevention services. So this graph is trying to make the argument, the person who made this graph is trying to make the argument that abortions have risen and life-saving procedures have declined over the last several years. So, and from the graph, it appears that abortions are a much larger portion of what Planned Parenthood does than cancer screening and prevention services. So why is this misleading? Well, first of all, notice that there's no vertical axis at all. So we don't have a sense of scale. What they did provide was the numerical values at each end of the arrow. So for the purple line on cancer screenings, there were about 2 million in 2006 and a little under 1 million in 2013. So the direction of the arrow is correct. Now let's look at the red arrow. The red arrow has a little under 300,000 abortions in 2006 and over 325,000 in 2013. So the direction there is correct. However, but there's two big problems here. First of all, 935,000, the bottom of the purple arrow, is larger, still significantly larger than 327,000, the number at the end of the red arrow. Yet the graph makes it look as though the number at the end of the red arrow is larger than the number at the end of the purple arrow. That's extremely misleading unless you look closely at the numbers themselves. Second, the scale is confusing. Right? 2 million to 935,000 versus 289,000. Just take a look at where those numbers are. Also, I just noticed this now, the ending point for the arrow should be higher, not just than the ending for the purple arrow, should not be just be higher than the ending arrow for the red arrow, but the purple arrow is also presented as being lower than the initial point for the red arrow. So the way around this is to put it, first of all, have a vertical axis, have a scale in your vertical axis, of course, start it from 0, and just plot your points and your arrows consistently with those axes. Now, one can argue that this is up to the reader to read this carefully, but I think it's better to be more honest with the creation of your graphs and not and the argument that the presenter is trying to make here would not be invalidated by creating this graph in what I would consider a more ethical manner, because after all, cancer screening and prevention services have declined. They've cut by half. Abortions have risen. You could another way to make this case a bit more honest is to look at the percentage change. Right? And I think there's a case to be made here, regardless of how you feel about abortion. However, this graph does so in such a misleading way that I would consider it to have crossed the bounds of ethics. Finally, correlation doesn't imply causation. Here's the graph of the obesity rate versus the poverty rate in the state of Michigan. There's a relationship here. So one might be tempted, even though you really want to switch the vertical and horizontal axis, so poverty rate was on the horizontal axis. There's a temptation to say that poverty rates, being in poverty causes obesity. And there's even a slight change in logic, because it's hard to eat well if you're in poverty, because it's the food that's cheaper is food that's worse for you. Healthier food is more expensive. So there's a case, but this data alone does not make the case that poverty causes obesity. It just says that there's a correlation. Right? And there's something called spurious correlations that you can find in data all over the place. I will put in the introduction page on Canvas a link to a web page that has lots of very amusing spurious correlations. My personal favorite is there's a correlation between the number of Nick Cage movies released in a year and the number of drownings in pools. Obviously, one doesn't cause the other, but yet the data shows a correlation. That concludes this section on graphs and charts. In the next section, we're going to have our final look at data visualizations, where we're going to focus on animated data as well as spatial data.